Hi, okay, welcome to this quick how to help video. We're looking at how we use trig ratios. It's something that can come into the foundation paper, and it's something that can be extended to quite a reasonable level through the higher. This is focusing on the type of thing we expect to see on a foundation paper, so you won't be seeing it to a higher level. The higher level will bring more surd work in and things like that. So to be able to answer these types of questions, you have to be able to recall a certain number of exact values. So it's down to being able to remember a whole load of different values. And that's why this can be quite tricky, because we've already got stacks to remember for our exam. So I'm a patterns girl, and I've learned how to do this by using a pattern. There is a hand trick, and I've put that link in the description, so you might be interested in looking at that, because that might be more your thing. For me, a pattern is all I need, and then I can get that into my head. So let me show you what I'm talking about. So the exact values are linked to the degrees, and we look at a certain number of degrees. So we look at 0 degrees, 30, 45, 60, and 90. So those are the values that we're going to learn. Now I put my sign and I arrow to those degrees. And then underneath, I put in the values, the pattern that I have learned. So it starts off 0. That's easy to remember because it just matches the top. And then my middle have divide by 2, and it ends with 1. So it goes 0 to 1 with my middle section all having divide by 2 over them. And then the numerators go 1, 2 with a root, 3 with a root. Technically, there is a root here as well, but the square root of 1 is 1, so we don't show it. So they are the values. So if I am now, like I am being asked in this question here, to write the exact value of sine 60, I can just travel along sine, get to 60, and my answer's right there, 1 mark. So it's an easy mark to get, but only if you can remember the values that are linked to each degree. Okay. Cosine is the sign backwards. Now, rather than rewriting these slightly harder numbers, I rewrite these and I write them backwards. So I have my cos pointing in that direction, and then I do 0, 30, 45, 60, and 90. And once that's in, I've got every value I need for sine or cos. So again, just to give you a couple of examples, if I needed to work out what the value of cos 30 was, travel along the cos runner, and your answer is there. So that's how I see my red labeling. They're like runners that I run up and down depending on the value that they give me. If I was asked to find cos 45, then I'm just traveling along the cos line till I hit 45, and my answer is there. So really, really nice and simple. And I can use it in a backwards way as well, which is nice. So if we take a look at this one, it says cos x is equal to a half. So there is a value for that x that's going to create a half. So I find a half in the table, and there's my answer. I'm on the cos runner, so x has to equal 60. So those are 2 possible kind of 1 marker questions that you may be asked. There is, of course, a third trig function, tan, which we've not mentioned yet. So tan works completely differently. I can't easily link tan to what we've done so far. It's a completely separate pattern that has to be learned again on its own. The hand trick, that's why I said home, because I had hand in my head. The hand trick doesn't easily work with the tan either. Tan is just a trickier one, full stop. So my tan, and I'm going to do my angles. We'll follow the same set of angles. It starts with the 0 again, which is quite nice. I like that, obviously. And this is where you've got to come up with something that just works for you. So I've got √3/3. Then it goes to 1. Then it's just the √3. And this is undefined. There is no value for tan 90. So there's nothing going in there at all. So pattern wise, I kind of, for me, my head says that's the most that I need to write. And then it's the only one with a denominator. It's coming up with something that works with you, for you. Make this your absolute priority. If it was me learning this for the first time, I would get this super, super secure. And then I would add this layer in second. Because if I try and do all 3 at once, the irregularity of this, the fact that the patterns are so much harder to follow, it could then confuse what you're doing here. Again, there are no 2s. Everything is 3s. And that's another thing that you can use to help you. So I'm going to just clean up this because obviously we've spoken about this. I'll leave the table because it'll save writing it out again. And then we'll bring this up and just take a little look at how we might apply this information to an actual question with a triangle. So let's say I am trying to work out this length here. I have to be super confident with trigonometry before I'm doing this. I probably should have said that right at the beginning. If your trig is a little dodgy, then you probably want to be working on that before you worry about this even. So I'm going to label my sides. I've got opposite here and hypotenuse here. So using SOHCAHTOA, which I will write out, I can see the O and the H are in this problem. So it's going to be this. So I'm going to be doing sine theta is O over H. Now, when I populate that with the information, I've got sine 30 equals the opposite, which is 20 over X. Now, I can put the exact value of sine 30 in, even though I haven't got a calculator, because I have got my sine 30 and it's coming out as a half. So I now know that sine 30 is a half. And I've got 20 over X this side. Okay. Let's bring that X across. I know it's not getting it on its own, but I don't want it as a denominator. So that's going to come across. And then I've got a half times by X because I've moved a divide. It's going to land as an X. So I now have that. I don't really need to go on and do any more rearranging. Half of a number I don't know is going to equal 20. That means X must be 40. So I'm using all of my knowledge, all of my skills with SOHCAHTOA, but I'm just not grabbing the calculator. For this step here, I'm using my table and then finishing it off by hand. Let's just do one last one. Let's say that the question had the X on the other edge. So we can take a little look at this. So let's say that the X was here. I'm still going to do opposite. This edge is adjacent. So it's the tan function. So I've got tan theta. So O over A. Now put in that information and I've got tan 30 equals 20 over A or X. In fact, let's put X because that's what the side's labeled as. There we go. I prefer that. So you use your table. Tan 30 is √3 over 3. So I've got √3 over 3 equaling 20 over X. Now that's feeling a little nasty. We've got to manipulate this in a way that means that I can work out what X is. I'm going to start off by taking this divide by 3 and moving it to the other side. It's going to land as times by 3. Okay, now remember 3 could be written as a fraction over 1, and we only multiply into that top value. So I've now got root 3 left on this side. 20 times 3 is 60, so I've got 60 over x. Let's move that up. Now I'm going to move my x over here. It's going to land as times, so I'm going to have root 3 times x equaling 60, and then that root 3 can land as a divide on this side. So my x is equal to 60 over root 3, and that is the answer. Technically, it could be argued that it can be simplified, which means that we need to bring in some surd knowledge. I don't think that expectation is huge on the foundation paper, but it's not impossible to be there. So I am going to finish this off. So it's a bit like cancelling fractions. I'm not changing the value. I am literally just rewriting it so there isn't a root as the denominator, because standard notation, the standard way that we represent our number is to not have that root as a denominator. So to get rid of it, I'm going to multiply by root 3, top and bottom. So the top's now going to have 60 times root 3, and it's just going to get squashed up. And the numerator, what's happening here is I've got root 3 times root 3. That would give me root 9, and the square root of 9 is 3. And that's why we multiply by the exact same number. I had root 3 here. Why did I times by root 3? Because this would happen, and I could get rid of the root because this creates a square number that can come out as a whole integer. And then this simplifies. How many 3's can I get into 60? 20. So I've got 20 root 3. Now, honestly, this is starting to go into what we see on a higher paper. This is correct. It's equivalent to this. And I think, don't pin me to the ground if I'm wrong. But honestly, I think this would be acceptable. I think that this is more of a higher expectation. And if in the future this proves to not be the case, then I will redo the video. So as a foundation pupil, your priorities are to learn the values. Learn the values. So if you're asked to write the exact value of sine 45, you can do it. That is the most common thing that I've seen on a paper. If they want to make it a little bit harder, they're going to bring an actual triangle into the problem, and then it's just work your way through. All of this extra is the type of thing that we expect to see for higher students. Anyway, I hope that you have found this quick how-to help video useful. And I will hopefully be able to help you in the future with some of my other how-to videos.